Okay, today's lesson is 6.1b, and we are going to cover row operations with 3x3 matrices. So this piggybacks on the first lesson that I talked about. And as I said, the 2x2, the process for 2x2, the steps of what you have to do, the three alternatives of multiply, alter a row, or interchange rows are the same. But the order that you do those steps is a little different when you have a 3x3 versus a 2x2. So I'm trying to simplify it as much as possible here, give you a little bit of flexibility when you do it. So this is what this little diagram means. So the first step that you want to do is you want to get a 1 in that spot right there. And think of it as columns. So you get a 1 and then you get a 0 in the other places in the first column. And then the second step is you move to the second column and get the 1, which is going to be right here. And then you go and get your zeros. Doesn't matter which one you do when. And then for the third step, you go to the third column and get your 1 and then get zeros in the rest of the places. So you're going to see me do that on these problems here. And to kind of minimize my space, I'm going to explain to you, I do more than one step each time, but what's important is you know how to get something on each row. Delta Math, you have to do one at a time. He writes it for you. You go through and do it. It's not a problem. But when you're having to write them all, you find out it's a lot nicer to be able to do more than one step at a time, more than one row at a time. Okay, so first off, you have to write the augmented matrices for this system of equations. So to start off, and remember, I suggested that you write them vertically. In Delta Math, it was easier to do it horizontally. It does not matter. It's just important to check yourself before you go to the next step, because if you miss this step, it throws everything off. Okay, so when I look at that, I have my x coefficients are 1, -3, and 2. My y coefficients are 2, -7, and 1. My z coefficients, -3, 9, -5. And my constants are 7, -12, and 8. Okay, so nicely, we have a 1 already in that spot. I'm working with the first column. So I have a 1 in that first spot. So now I need to get zeros in the other spots of the column. Doesn't matter which one you do. I'm just going to happen to go to this one first. And you use the 1 to get zeros. You use the 1, or, I mean, you can use anything to get to the 1. But if you have a 1, it's easiest. And you multiply by the opposite of what you need, what you have here. So I'm going to multiply this row by 3. I'm going to change the second row. So in Delta Math, you would say alter the second row. And I'm going to do that by multiplying the first row by 3 and adding it to the second row. So when I do that, I am not changing the first row. So I'm writing it the same. Nicely enough, Delta Math does that for you. So you tell it what you're going to do, and puts everything else the same. So I'm going to think 3 times this number plus that. So 3 times 1 plus -3 is 0. Okay, 3 times 2 is 6 plus -7 is -1. 3 times -3 is -9 plus 9 is 0. And 3 times 7 is 21. 21 plus -12 is 9. Okay, now I'm going to go make this spot a 0. So I'm going to change the third row. And when I change it, I'm going to multiply by the opposite of that number. So I'm going to multiply by -2 and then add it to the third row. I'm using the 1, so that's why it's -2 times row 1 plus row 3. So -2 plus 2 is 0. Okay, I'm multiplying this right here. -2 times 2 is -4, and -4 plus 1 is -3. -2 times -3 is 6, and 6 plus -5 give me 1. And then I have 7 times -2 is -14, and -14 plus 8 is -6. Okay? So I am done with the first column. I have a 1 and I have zeros. Now I'm moving to the second column, And I need a 1 here, but I have a -1, so for all practical purposes, I have it. I'm going to multiply everything by a -1 to make it 1. But now I'm going to go ahead and use this to get zeros here and here. So if I multiply this row by 2 and add it to that row, then I'm going to have a 0. So I'm going to come up here and I'm going to say 2 times row 2 added to row 1. And that's going to give me 2 times row 2. So 2 times 0 plus 1 is 1. Okay. 2 times -1 plus is -2 plus 2 is 0. 2 times 0 plus -3 is -3. And 2 times 9 is 18 plus 7 is 25. Okay. I'm going to use this same row because that's the one with the 1 in it. And this time because I'm using that row, I'm going to multiply this one by -3, because when I multiply this by -3, I get +3, and when I add that to -3, I get 0. So I am changing the bottom row, and I'm multiplying row 2 by -3, adding it to row 3. So my 0 is going to stay 0. 3 plus -3 is 0. 0, right here. 0 times -3 is 0, and 0 plus 1 is 1. And then 9 times -3 is -27. And -27 plus -6 is -33. And now I'm going to make a 1. That first row I'm going to multiply everything by -1 so that it's a +1. And that's going to give me 0, 1, 0, and -9. So now I am done with the first column. I'm done with the second column. And I'm on the third column. Well, I happen to get a 1 here, happen to have a 0 here. So the only thing I have to worry about is this one right here. So when I go to the next one, and I'm going to change that top row, my bottom 2 rows stay the same. I'm going to multiply the row 3 by 3 and add it to row 1. So 0 times 3 plus 1 is 1. 0 times 3 plus 0 is 0. 1 times 3 plus -3 is 0. And then -33 times 3 is -99. Plus 25 is -74. So now I have my reduced row echelon form. I have 1s down my diagonals, and I have 0s above and below it. And that tells me that x equals -74, y equals -9, and z equals -33. And properly written, that would be an ordered triple. So that's what I have. That's your x, that's your y, and that's your z. Okay, next one, just so that you can hear that process one more time. All right, so I have my my first augmented matrix, and I'm going to have -1, 4, 2. Okay, so you can't do this on Delta Math, so just be careful. I went ahead and switched these 2 rows, okay, because I wanted my 1 up top. So I don't think Delta Math will let you do that. You would actually have to write it just like this, and then you have to tell Delta Math to interchange the rows, okay? So that means my next one's going to be -2, 9, and 4. The next one's be -4, 16, and 9. And then I'm going to have -1, 2, and then 5. Okay, so I have this -1 up here. So yes, I'm going to change that, and but then I'm going to use that row. I'm going to use this row because then I'm going to multiply it by 4 and add it to this guy, and multiply it by 2 and add it to that one. So let's do the second one first. 4 times row 1 plus row 2, and that gives me 0. 4 times row 1, 4 times -2 is -8, plus 9 is 1. Okay, y'all, the nice thing about this notation is you can just sit there and say 4 times -2 plus row 2, which is 9. Okay, 4 times -4 is -16, plus 16 is 0. 4 times -1 is -4, plus 2 is -2. All right, similar thing, I'm going to multiply that top row by 2 and add it to row 2. So -2 and 2 is 0. All right, I'm multiplying the top row. So 2 times -2 plus 4, that's going to be 0 again. 2 times negative 4 is negative 8 plus 9 is 1. 2 times negative 1 plus negative 5 is negative 7. Okay, and just like I did last time, I'm just going to multiply everything in the top row by negative 1, so it changes the sign of all of my terms. Okay, so I have done the first column. I'm on the second column. Well, the 1 already came through for me, so I just need to get this to a 0. So how do I get that to 0? I'm going to use this row. I'm going to multiply it by the opposite of that. So row 2 times negative 2 added to row 1 is going to give me a new row 1. Negative 2 times row 2 plus row 1. Okay? I don't need to change the bottom row because I already have what I need. So negative 2 times row 2 is negative 2 times 0 plus 1 is 1. Negative 2 times 1 plus 2 is 0. Negative 2 times 0 plus 4 is 4. And negative 2 times negative 2 is 4 plus 1 is 5. Okay, and now the only thing I have left to do is I have that column has a 1 and zeros. This column has 1 and zeros. This column has the 1, but I need a 0 right here. So everything is going to stay the same except for I'm going to change that top row. And when I need to get a 0, I'm looking in that column for where there's a 1. That's the easiest way to do it. Okay, there are other ones. If you need help with your matrix, please come see me. All right, so I'm going to multiply row 3 by negative 4 and add it to row 1. So the bottom two rows stay the same. 0 plus 1 is 1. 0 plus 0 is 0. Negative 4 plus 4 is 0. And so now I have negative 4 times negative 7, which is 28, plus 5 is 33. We got another 33. Okay, so my order triple is going to be 33, negative 2, negative 7. Okay, that's your X, that's your Y, that's your Z. That's your X, that's your Y, that's your Z. Okay, last two problems. Sometimes you're going to get a matrix that has no solution, and sometimes you're going to get it when it says many solutions. So I'm going to show you, I did this in class calc and had a little snafu in the program. So this time I'm going to use Desmos. They're very similar, okay? Might not always have Desmos with you, and by the time you need it, I'm sure class calc will be fixed and ready to go. So I'm going to take this one right here, and I'm going to go put it into the calculator because it's, we just did two of them. We don't need to do another one. So this is what you do in Desmos. You type a new matrix. Okay, my matrix is, I have 3 rows, but I have 4 columns. So I'm going to go put that guy in. 3, negative 1, negative 5, 9, 4, 2, negative 3, 6, negative 7, negative 11, negative 3, and 3. And just like we had in class calc, RREF, matrix A, and look at your answer. Now this is a little interesting thing. This little thing, nice little thing in Desmos, it converts it to fractions. Okay. When I did this originally, okay, it came out as fractions. So that's what I have in my answer. But notice, y'all, that we have a row of zeros on the bottom. Okay. So let me explain to you what that means. So this particular matrix, when we did the REF, looked like that. Okay. Now, what this tells you, okay, remember that these are the X coefficients, these are the Y coefficients, and these are the Z coefficients, and those are the constants. So this says 1X minus 1.3Z equals 2.4. Okay, so that's what the first equation is. X minus 1.3Z equals 2.4. The next one says I don't have any X's, but I have 1Y and 1.1Z equals negative 1.4. Excuse me, negative 1.8. Okay? And more importantly, the bottom row says Z, 0Z equals 0. Well, that is a true statement. 0 equals 0. And so this is the kind of problem that says you have infinitely many solutions. And the solutions are like this. And what you do is you just take this and solve for x. So you move this guy over, take that, solve for y, move this guy over. And so your answer is an ordered triple that looks like that. See, if I added 1.3z, then I would have this right here. There's my x. This part is my y, and that's part my z, because I got 0 equal to 0. Okay, now let's go do this last one real quick. I'm going to hit enter, make that go away. And this time I'm going to do another matrix. Again, I need 3 rows and 4 columns. And it is 1, 3, 4, 8, 4, -2, -1, 6, 8, -18, -19, and -2. So when I put that in and hit my RREF for matrix B, notice what I get right here. Okay, if you want it in fraction form, it looks like that. Okay, but I'm going to go back here and write it down. So when I pull this one out, or copy this one down, however you wish to call it, okay, notice that my bottom row, that's the same kind of thing that we had here. 1x plus 5/14 z equals 0. 1y plus 17/14 z equals 0. But this says 0 equals 1. Can 0 equal 1? No, it cannot. So this is a false statement. And so this is an example of no solution. So if you get all zeros on the bottom, then you have infinite solutions. If you get zeros on the left equal to a number, that's false, and you have no solution. And that is all there is to 3x3 matrices. If you have any questions, please don't hesitate to contact us or come see us. Thank you so much, and y'all have a great day. Bye.